Hello, everybody. Happy Wednesday. Not gonna lie, I made this video once and it was confusing, so I'm trying again. So today we're going to be talking about the metric system and dimensional analysis. So the metric system is what scientists use, not what we use here in the United States. So we're going to be seeing it a lot in our class. We're going to be seeing the metric system, so we need to learn how to convert between units in the metric system, and we're also going to be going over briefly dimensional analysis. All right, so the metric system is broken down. There's different units that we can use. So we have liter, which is going to be volume, and the imperial system, or what we use, equivalency, would be like gallon. All right, and within that, then we have cups, that kind of stuff. Meter, this is distance. This is similar to our mile. And then grams, this is mass, similar to pounds, kind of. And then joule, this is energy. And calorie is also a unit of energy in the metric system. We're going to be using these throughout the year. These are the different units. All right, so then for each of these units, we also have the metric prefixes. So the reason that scientists like to use the metric system is because it's base 10. And the metric system is scaled using the metric prefixes. So this one right here, this is the meter, liter, gram, joule, and calorie. And then we can use the metric prefixes, the milli, centi, deci, deca, hecto, and kilo, to scale those different units. So for example, we can have a milliliter, a millimeter, a millijoule, or a millicalorie. And when I say that it's a base 10 system, if you start with 1 meter here, a decimeter is going to be 0.1, or no, oops. A decimeter, a decimeter is going to be 10 decimeters. 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. So as you see, when you're going to the right, it goes up by base 10, which means you multiply by 10. So between each one of these, you're going to do times 10, times 10, times 10. If you're going the other direction, going to deca, hecto, and kilo, it's still base 10, but instead of multiplying by 10, you're dividing by 10. So 1 meter is 0.1 decameter. 1 meter is 0.01 hectometer. And 1 meter is 0.001 kilometer. So instead of multiplying by 10, you're dividing by 10. All right, so that's what I mean by base 10. All you have to do to convert from liters to milliliters is multiply by 10, by 10, by 10. So it's really easy once you understand how those prefixes are scaled. All right, so let's practice. Oops. All right, so I want you guys to pause, see if you can figure this out on your own based on what I just went over. All right, hopefully you paused, hopefully you tried it. If not, that's fine too. I'm going to explain it anyways. All right, so first thing we need to do is get our prefixes across the board. So I kind of forgot to say this. I'm going to go back a slide. If you remember the metric prefixes, a good way to remember them is by my cat, Donna Marie, doesn't have kittens. Those are the metric prefixes. My cat, Donna Marie, doesn't have kittens. All right, so first thing we're going to do is we're going to write across the top the metric prefixes. My cat, Donna Marie, doesn't have kittens. All right, so remember this right here is going to be like liter, meter, joule, calorie. This over here, this one right here is milli, kilo. My cat, Donna Marie, doesn't have kittens. All right, good way to remember that. So I'm asking you to go from milliliters to liters. All right, so we have 4,593 milliliters. An easy way to do this is, so you could say, okay, if you go left, remember you always divide. If you go right, you multiply. So we're gonna divide 4,593, divide by 10, divide by 10, divide by 10. An easier way to do this, instead of dividing, an easier way to do this is to just move the decimal. All right, so we started with 4,593. If we divide by 10, we're going to move the decimal one place. Divide by 10 again, that gives us centimeters. That gives us decimeters. Divide by 10 again, we're at 4.593 liters. So an easier way to do this is just to count. So we went 1, 2, 3. We moved our decimal 1, 2, 3. And when you're counting between the prefixes that you want to convert to, if you go to the left, you're going to move the decimal to the left. If you go to the right, you're going to move the decimal to the right. All right, so let's try an easier one before we get to number 2. So again, we're going to do my cat, Donna Marie, doesn't have kittens. All right, so let's say we had 5 kilometers and we want to get it to meters. So all we would have to do is go 1, 2, 3. All right, so we're moving to the right, which means we're multiplying times 10 times 10 times 10. So we're going to go put our decimal point here. We moved it 1, 2, 3. Just move it 1, 2, 3. Fill in with zeros, and we have 5,000 meters. All right. So if the whole moving the decimal confuses you, feel free to just remember, if you're moving to the right, you're multiplying by 10. Moving to the left, you're dividing by 10. All right. So let's do number 2 together. So my cat, Donna Marie, doesn't have kittens. All right, so we're at 3 kilometers squared. So if you follow what we just did, you might be thinking that this is 3,000 meters squared, but that is wrong. All right, so the reason it's wrong is because we have it squared. I'm going to erase again. All right, so we know that 1 kilometer equals 1,000 meters. All right, we know that from the My Cat Donna Marie Doesn't Have Kittens. So what we need to do is square both sides. So 1 squared, remember that's going to get us to our kilometer squared, is 1. 1 squared, 1 times 1 is 1. 1 kilometer squared equals, so now we're going to do the same thing over here. 1,000 squared, 1,000 times 1,000 is 1 million. All right, so 1 kilometer squared is 1,000,000 meters squared. So now that we know that, 3 kilometers squared is we just multiply this times 3. All right, 3 million meters squared. All right, so this is how we do metric conversions using my cat Donna Marie doesn't have kittens, and either multiplying by 10 or dividing by 10. And remember, all you have to do if you're just multiplying or dividing by 10 is move some decimals. It's pretty simple. Okay, next slide. So dimensional analysis. Some of you, if you've taken chemistry, you've definitely done this before, but we actually do it all the time in our heads. So a car goes 50 kilometers per hour for 2.5 hours. How far does the car travel? So we know that if we want to figure out the distance, the car traveled, all we have to do is multiply this number by 2.5 hours. All right, so if we do 50 kilometers per hour times 2.5 hours, we're going to get 125, kilometers. You just did dimensional analysis in your noggin and you didn't even know it. Pretty crazy. All right, so dimensional analysis we use all the time without really knowing it, and this is how dimensional analysis works. So quick, brief intro. It does unit conversions and helps you problem solve. So if you know what units you need to get to, it's really useful. It's basically you set up a long multiplication problems where the units cancel out, which is very similar to algebra where you would cancel out variables. So for example, if you had like 2x over 5 times 3 over 4x, you know that when you do this, the x's are going to cancel and you're going to get 6 over 20. All right, so you've already done the whole canceling thing before where you cancel out variables. It's the same thing, but with units. So those liters, milliliters, joules, miles, hours, all of those units we're going to be canceling out. So dimensional analysis, the answer is right when all of your units cancel out in this long multiplication problem you're going to make, which I'm going to show you. So we're going to use dimensional analysis to do the problems that we did before. All right, so 4,593 milliliters. All right, so when you set up this problem, you need to think about, I want my units to cancel. That's the whole point. And we know that the units cancel if we have the units on top and the units on bottom. So we know milliliters is going to go on bottom because we want them to cancel out. Liters go on the top. So now we just need to figure out how many milliliters are in 1 liter. So for every 1 liter, going back to my cat Donna Marie doesn't have kittens, I'll write it up top again. So going back to that, we know that in 1 liter, there's 1,000 milliliters. If we start here, move our decimal place, we have 1,000 milliliters. Then you're just going to multiply, cross off the units, which we already did, cross off milliliters. Do 4,593 divided by 1,000, 4.593 liters. All right, so same thing below, 3 kilometers squared. All right, we want our units to cancel, so we know kilometers squared goes on the bottom, and we want to get to meters squared, so that goes on the top. Now we just need to figure out how to convert from kilometers to meters. So for every 1 kilometer squared, we have 1,000,000 meters squared. Our units cancel, so now we're in meters squared, which is what we want. Just going to multiply across. 3 times a million, 3 million meters squared. All right, that is very easy dimensional analysis. It is going to get harder, I promise. All right, so the first thing you really need to do is set up the number so that the first units are on top. So let's say we wanted to convert, I'm telling you I want to convert 50 kilometers per hour. I want that into meters per minute. All right, this is a great dimensional analysis problem. So the first thing you need to do is set it up so that the first units are on top. All right, so our first unit here is kilometer. So we're going to do 50 kilometers for every 1 hour. Then you need to figure out what you need to convert and how to convert it. So the first thing we need to do, we want our units to cancel, is figure out how to convert kilometers to meters. So we know that 1 kilometer equals 1,000 meters. And we also know we need to go from hours to minutes, and we know that 1 hour equals 60 minutes. All right, so those are the conversions we're going to need here. Step 3, using your conversions, these here, we're going to set up the conversion for the top unit, kilometers. All right, so we want our units to cancel, so we're going to put kilometers on the bottom. That way they cancel out. We're going to put meters at the top. So looking back at our conversion here, we know that 1 kilometer, there's 1,000 meters, and that is our first conversion. So if we were to multiply this out, we would now have meters per hour. But remember, I'm asking you to turn hours into minutes. All right, so we're going to set up our second conversion. So hours is on the bottom, so we know, because we want to cross off our units, that we're going to put hour at the top, minute at the bottom. All right, that way we cross off here, and now we're in meters per minute. So for every 1 hour, there is 60 minutes. Now we're done, because we have the only units left are meters per minute, which is exactly what we wanted our units to be in. All right, so now you would just multiply across the top. So this would be 50,000 meters divided by 60 minutes. Feel free to use the calculator, which I'm going to be doing here because this is a weird number if I can get my calculator up. Then you're just going to divide 50,000 divided by 60, 833 meters per minute. And that right there is our final answer. All right, so that is dimensional analysis, a little more tricky, if you will. I'm going to clear all of this off. Feel free to rewatch all of that as much as you need to, all right? So I want you to complete your work in your interactive notebook. So I'm going to briefly show you what I want you to do. All right, so you need to practice this. All you have to do is type in your answers into the box here and type your answer here. All right, so I'm kind of setting up the work for you for the first 2 problems. For the rest of these problems, you have to choose which cards you are going to use for each problem. So not all of the cards will be used. So it says a 150 square mile forest is about to be sold for $3,000 per hectare. How much money will be made in the sale? So the first thing you need to do, you're going to move this down 150 square miles. That's what we're starting with. Then you need to figure out which one you're going to use to convert this into acres. All right, so we have acres, hectares, and then we also have money. So if 150 square miles is on top, you know that you want square miles on bottom. All right, so then you're going to move down the next card. And down here is where I want your answers to be, or want the squares to be. Eventually, you're going to have an answer here. All right, so you're using these. I'm going to put this back. You're using the cards, and you're going to arrange them in your dimensional analysis equation, and then you're going to write your answer in this box. So you're going to have to type your answer here. Answer. Right, so you're arranging the squares in the order that you would use for dimensional analysis. So I'm already giving you the conversions. All you have to do is arrange those squares. You only have to do through practice problem 5. The rest we will be working on as a class tomorrow. If you have any questions, I do have office hours every single day from 2 to 2:20. So please feel free to stop by if you have questions. All right, I think that is it for today. Let me know if you have questions. I will see Group A tomorrow.